Good day, class. I'm here to discuss about linear programming, maximization, and minimization problems with mixed signs. Sige, basahin ko muna yung ating unang problem. Grace wants to invest in a total of 50,000 pesos in either best fund or time deposit or both. Okay? The best fund pays 8% per year or per annum, and the time deposit pays 9% per year. Because the best fund is riskier than the time deposit, she intends to put at most 30,000 pesos into the best fund and at least 10,000 pesos into the time deposit. How much should she allot to each investment in order to maximize her returns? So we let X amount invested in the best fund and Y as amount invested in time deposit. Our objective, no class, is to maximize. So, nababasa natin yan sa tulo. Madalas mababasa natin yan sa huling statement ng problem. And then, this is a linear programming maximization problem. Actually, it is a investment problem, no? So, here we have a investment problem. Okay, so we are now to create the table, our first step. So, meron tayong X column and Y column. Then, a column for sign and the parameters or the right-hand side values. Following dito naman sa pinakakaliwa is the investment or the returns. So, sabi dito, Grace wants to invest a total of 50,000 pesos in either best fund or time deposit or both. So, take note, kung may nakita kayong words na or both, ito yung ating susundin. So, ibig sabihin, ang sign natin, pag or both, is equal. No? 50,000 pesos. So, it is both best fund and time deposit. So, this is the total invested constraint. Then, meron pa tayong additional constraint. Sabi dito, because the best fund is riskier than the time deposit, so she intends to put at most 30,000 pesos into the best fund. So, yung best fund natin is much riskier. Kaya at most, so ang sign ng at most is less than or equal. No? Best fund less than or equal 30,000 pesos. While sa time deposit, no? Time deposit or time deposit, so we have Y, we have at least or greater than or equal. No? Pag sinabing at least, the sign is greater than or equal. So, at least 10,000 pesos. And then, sa last column, yung ating objective is maximize. So, we maximize our P or profit or investment. Sabi dito, no, mababasa nyo naman, the best fund pays 8% per year. So, imbis na monetary, meron tayong ginagamit dito na in percent. So, yun yung gagamitin natin. So, 8% to decimal number, 8 divided by 100, we have 0.08. And then, sa time deposit, yung 9% convert to decimal number, that is 0.09. So 9 divided by 100. Okay. So yung LP model natin, so we have objective function max p is equals to 0.08 x plus 0.09 y, subject to three constraints. We have x plus y is equals to 50,000. We have x is less than or equal to 30,000. Y is greater than or equal to 10,000. And then both x and y should be greater than or equal to 0. So we are going to assign this as equation 1, this as equation 2, and we have this as equation 3. Okay, igagraph natin ngayon sa third step yung tatlong constraint. So muna tayo sa first constraint. So if x is 0, y is 50,000. If y is 0, x is 50,000. So dito siya, ang ating unang equation. And then take note that yung kanyang sign is equal. Pag equal sign, ang shading niya is along the line. Papakapalan lang natin to. So take note, if ang sign natin is equal, the shading is along the line. Okay, for the second line or the second constraint, x is equals to 30,000. Ang line natin dito is vertical line. Okay, sorry. So we have a vertical line. Yan. And then take note that yung sign natin is less than or equal. So we shade to the left. No, we shade to the left. We shade to the left. Okay, so we have the third equation. So y is equals to 10,000. Ito yung 10,000. So we project a horizontal line. And then take note of the sign that is greater than or equal. So we shade above the line. Okay, above the line. Okay. So ngayon, titingnan natin yung kanyang corner points. So corner points ng feasible region, no? So mapapansin niyo nandito lahat siya nagkakaroon ng common shading. Since yung red natin is along the line yung shading, dito lang tayo, nandito lang within this line lang part na ang feasible region natin. So we have two vertex kung ano nyo, no, analyze nyo. Unang vertex yung dito, first vertex, and the second vertex is here, no, kung saan sila nagkaroon ng common shading. So dito sa part na to wala, no, dito walang common kasi ang shading natin sa red is along the line. So ibig sabihin nandito lang. So kung ano natin siya, bibigyan natin siya ng highlight. Ito ang ating feasible region. Okay? And then these two our vertices. So ito, this vertex is 0 and 50,000, and then this vertex is 30,000 and 20,000. Or you can simultaneously the two lines para makuha itong 30,000 and 20,000. So therefore, we have two vertices. Lagyan na lang natin 30K and 20K. Ito yung nasa baba. So yung profit natin yan, yung kung iaano natin, isa-substitute natin yung 30,000 and 20,000 dun sa ating objective function. Ito, we will get 4,200. Kung dito naman sa isa, we have 0 and 50K or 50,000. Kung ipapasok natin yan doon sa ating objective function sa x and y, ang makuha natin is 4,500. Okay? So since ang hinahanap natin is the maximum, no? We have max p, our answer will be the highest, which is 4,500 at 0 and 50,000. So our decision statement, Grace must invest only, no, to time deposit, which is the y, which is $50,000 or pesos pala rather, 50,000 pesos, in order to earn a maximum return of 4,500 pesos per year on investments. Okay? So that is example number 1. Punta tayo sa ating example number 2. I will read. The Alpha company needs to produce 40 units of product A tomorrow. They can produce on either machine X and machine Y or both. Each unit of product A, when processed on machine X, takes 30 minutes of time, while a unit processed on machine Y takes 25 minutes. It costs the company $2 per minute and $3 per minute respectively to operate the machines X and Y tomorrow. Machine X has only 10 hours available to produce product A, while machine Y can be operated as long as desired. Determine how many hours to schedule each machine to minimize the production cost. Let X be the number of hours to schedule on machine X and Y as the number of hours to schedule on machine Y. Okay, so kung babasahin natin, our objective is to minimize production cost. So minimization problem tayo. And this minimization problem is a machine utilization problem. So this is an example of a machine utilization problem. So, di ba naalala niyo yung mga example natin? Mga nauna are examples of product mix problem by mga unang examples natin. And then, yung kanina lang, that is a investment problem. Ngayon, this is a machine utilization problem. Okay, so we are going to create the table. So, we have here the constraint. Then we have x and we have y and sign and parameters or the right hand side. So sabi dito, the Alpha company needs to produce 40 units of product A tomorrow. So sabi diyan, so pagka ang analysis natin diyan is dapat makapag-produce sila ng product A. So yung product nila is product A lang, no? So makapag-produce siya ng 40 units. So ibig sabihin, pwede siyang sosobra or pwedeng 40 units mismo. So we write here greater than or equal 40 units. And then what is for x and y? So makita natin we have each unit of product A when processed on machine X takes 30 minutes of time. So in an hour, we have 60 minutes. And then it takes 30 minutes of time per unit sa machine X. So we have 60 divided by 30. So ibig sabihin, we have 2 units, no, for X. And then sa Y naman, no, we have it takes 25 minutes. So ibig sabihin, sa isang oras, 60 divided by 25, sa isang oras we have 2.4 units. So papansinin nyo, yung unit of measurement nila, pare-parehas siyang units, no? So that is the first constraint, which is the processing. So moving on to our second constraint is the machine availability. So we have 2 machines. For machine X, sabi dito, hanapin natin, no? Machine X only has 10 hours available. So machine X, so pag sinabing only, should be less than or equal to 10 hours. No, yung only. So we have 10 hours. By the way, pwede nyo namang hindi isulat ito, no? Pwede nyo nang hindi isulat yan. Okay, pwede nyo siyang hindi isulat. And then, so this is blank. Yung sa machine Y, so blank yung X, machine Y. Machine Y can be operated as long as desired. So pag sinabing as long as desired, in the first place, ang target dito, 1 day lang. Kasi nabasa nyo yung word na tomorrow. So, 1 day is 24 hours. So, as long as desired, ibig sabihin, should be less than or equal to 24 hours. Meaning, isang araw. Okay? So, and then our objective, since minimize production cost, we have min C. And then, mapapansin natin dito, no, it cost the company $2 per minute and $3 per minute, respectively, for X and Y. So, yung $2 per minute, ko-convert natin sa isang oras. So, we have 2 times 60. We have here $120. No? Sa Y naman, $3 per minute. So, we have 3 times 60 equals 180. Okay, that's the table. So, ngayon, gagawin natin yung LP model. We have min C is equals to 120. Ito, no? X plus 180. Y subject to 2x plus 2.4 y greater than or equal to 40. So, ito yun, di ba? Ito naman, we have x less than or equal to 10. Ito namang third constraint, we have y less than or equal to 24. And x and y should be both greater than or equal to 0. So we have a 2 by 3 problem. 2 variables and 3 constraints. Now we are going to graph. So let this be equation 1. This as equation 2 and equation 3. So sa equation 1, kung ano natin yan, sa substitute natin x is 0 and y is 0, makukuha natin x is 20 and y is equals to 16.67 in 2 decimal place. So y niya, probably nandito siya. No, yung x niya is 20 nandito yan. So i-ano natin yung line. So yan yung una nating line. Next, yung ating second line. And then, by the way, yung ano natin pala class, yung ating sign is greater than or equal. The shading is above the line, di ba? Shade is above the line. Okay? For our second constraint, so second constraint is x equals to 10. Di ba? So, saan yung x is equals to 10? So, ito siya, no? Vertical line. Ayan. And then, ang ano natin, sign is less than or equal. So, ang shading natin is to the left of the line. And lastly, yung third equation. So, y is equals to 24 to. So, saan yung 24 natin dito? Dito siya. So, this is a horizontal line. Oh, sorry. Medyo hindi dumiretso. So, horizontal line. So, ganyan siya. And our sign is less than or equal. So, we will shade below the line. So, below the line, we'll shade below the line. Yan. And the region, class, the next is the region. Hanapin natin yung region ng which has the common shading among the three lines. Mapapansin natin, ito siya. Okay. So, kakapalan lang natin yung ating pen. So, una dito. Then, we have here. Then, meron tayo dito. And, meron tayo rito. Okay. So, kung ano natin, ititrace natin yung kanyang figure, ganyan na itsura niya. So, we have this figure and then the shade na. Yan. And then, now, yung fourth step natin is to determine the vertices. So, we will determine the vertices. So, yung dito, we have 0 and 24. Itong kanto na to. Ito naman, this is 0 and 16.67 in 2 decimal places. Ito naman, we have 10 and 24. Ito. And then, itong kanto na to, corner, that is 10 and 8.33. So, paano natin nakuha yan? So, yun dito, no, itong vertex na to, we can solve the two lines simultaneously. Okay? So, also, we can solve this one. Pero makikita mo naman, this is at 24 and 10. Or 10 at 20 and 24. So, ito lang yung line na to. These two lines can be solved simultaneously para makuha yung 10 and 8.33. Now, we will solve for the, or the step number 4, we'll solve the costs. So, we have the four vertices. We have 0 and 16.67. And then we have 0 and 24. And 10 and 24. And 10 and 8.33. So, kung sinubstitute natin yan sa ating objective function, kung substitute natin siya dito, makuha natin dito ay $3,000. Dito naman ay 4,320. Dito sa pangatlo is 5,520. And the last is 2,700. Since our objective is to minimize, so ito ang pinakamaliit na value. Okay? And then for our decision statement, the company must schedule 10 hours on machine X and 8.33 hours on machine Y to minimize total production cost to only $2,700. Okay, thank you very much. God bless, and don't forget to subscribe.